everyone, it's Judy here again, and I'm going to talk to you in this video about how to prepare standard solutions. So what is a standard solution? A standard solution is a series of dilutions of a substance that contain accurately known quantities or accurately known concentrations of that element or of the substance that they contain. So we use them quite often in numerous chemistry labs to allow us to determine the concentration of a substance when the concentration is unknown. So if we have a series of dilutions, we can use that to make up a calibration curve, and then you can measure your unknown solutions and compare it to that to get an accurate concentration. So we're going to start with making up a stock solution. So the stock solution is the solution of the highest concentration that we make up from the powdered form or the solid form of the substance, and then we dilute that down, okay? Because if we think about making concentrations or making up solutions that have very low concentrations, it would be very difficult for us to measure out very, very small amounts of a powdered substance. So the series of making up dilutions allows us to take a more concentrated solution and then dilute it down to get accurate concentrations. So that's the reason why we use standard solutions. So today we're going to start with making up a series of fluoride standards. So we're going to use sodium fluoride for that. So this is the powdered form of sodium fluoride. So how do we know how much we have to weigh out to make up our stock solution? Well, there's a calculation we can do to give us that amount. So if we look at sodium fluoride, it's NaF. The molecular weight of that sodium fluoride compound is 41.99 grams per mole. That's generally given on the bottle, but you can easily calculate it using the molecular weights from your periodic table. So that's the molecular weight of the compound, the sodium fluoride. But for our purposes today, we're only interested in knowing the quantity of the actual fluoride that's in there, because that's what we're looking for analyzing in our experiment. So the molecular weight of fluoride from your periodic table is 18.998 grams per mole. So the calculation that we use to determine the amount that we actually weigh out, we take the molecular weight of the compound that we have, we divide that by the molecular weight of the element that we're looking for, in this case is fluoride. So 41.99 divided by 18.998, that gives us 2.21 grams. So if we weigh out 2.21 grams and we dilute it down to 1 liter, so this calculation only works if the volume is exactly 1 liter or 1,000 milliliters. So we take 2.21 grams, we measure that out using a scale. You want to have at least 2 decimal places on your scale. And then we dilute that down to 1 liter in a volumetric flask. So this is a volumetric flask. If we measure out our water up to the line, that's exactly 1 liter. So I'll show you how to do that in a second. So let's measure out our sodium fluoride first. So I'm just going to zero off the scale here, put a weigh boat on, zero it again. So I want 2.21. Just a little bit more. There we go. 2.21 grams. And now I'm going to add this to my volumetric flask. So these weigh boats make nice little funnels if you just fold them like this. Then you can add your powder to your volumetric flask like this. Now again, we want to have very precise control of the amount we're adding. So in case there's any little particles left in my weigh boat, I'm going to take some water and rinse out that weigh boat so I make sure all of my compound is in my flask. And then when I have all of that done, I'm also going to rinse down the edges of my flask to make sure it's all in the solution. Okay. Now I'm going to fill it up probably about 2/3 of the bulb of the volumetric flask, and then I'm going to make sure it's all dissolved. So I'm going to start by filling that up with water now. So it's all dissolved here now. You can see there's no crystal or powder left in our solution. It's all completely dissolved. So when I get close to the line, so you see the line right here, it's a faint line, but you can see when you get close. That indicates that it's exactly 1 liter. So when I get close to that line, I want to slow down with adding my water because I don't want to overshoot or add more than 1 liter. So I need to be exactly on that line. So I'm going to slow down. I'm going to take my dropper bottle and I'm going to get it eye level with that line so that I can see exactly how much I'm adding. You can see that it's going up here slowly. So the meniscus is the curved surface of the solution. You can see it right here. So that curved surface. So the bottom of that meniscus should be just sitting on that line, just touching that line. So you can see right now I'm below it. So I need a little bit more. And at this point you almost want to just do a drop at a time so that you don't go over. There we go. So you can see right now that the bottom of the meniscus is sitting on that line. So that means that it is exactly 1 liter. So now I want to make sure that the sodium fluoride that's in there is mixed throughout the solution, that is uniform. So I'm just going to take some parafilm and cover my cap here and cover my top. I'm just going to invert it a few times to make sure that it's all very well mixed. And you can do this if your powder doesn't all dissolve at the beginning either. You should make sure that your powder is all dissolved before you top it up to the line. Okay, good. So that is our stock solution, 1000 ppm. So we don't often work with solutions that are that high in a concentration. So we want to dilute it down to lower concentrations. So we're going to start with diluting it down to 100 ppms. Okay? So how do we dilute something down to 100 ppms? Well, we're going to take a certain amount of the stock solution, we're going to put it into the smaller volumetric flask, and then like we did with the bigger one, we're going to top it up to the line. So there is a calculation or a formula that will allow us to calculate how much of the first solution we have to take out to put into the second solution. So the formula is C1V1 equals C2V2. You'll sometimes see it written as M1V1 equals M2V2. It means the same thing. One is concentration, one is molarity. But it means the same thing. So you can think of that formula as representing 2 different solutions. So the C1V1, that's for solution 1. That's our stock solution that we just made. And this C2V2, the second solution, that's the one that we're making that's a lower concentration. That's the one that we're diluting. So where do our values come from, our C1V1, C2V2? The C1 is our concentration of the first solution. So that's the one we just made up. Okay, so this solution we're going to call solution 1. The one we're putting into a small flask, that's going to be solution 2. So C1 in this case is our 1000 ppm. That's the one we just made up. Okay. So V1 is the amount of this solution we're going to take out to put into the smaller flask. So that's what we're trying to solve for, is what we're looking for here. Okay, so V1 is 1000 ppm. C1 is 1000 ppm. V1 is what we're looking for. C2 is the concentration that we're trying to dilute it down to. So we're diluting it down to 100 ppm. So that's the concentration we want to have in this flask. So that's going to be C2. And V2 is the volume that we're diluting it down to. So this flask is 100 milliliters. So that's going to be your V2. So if you solve for V1, in this case, we're going to use 10 milliliters for V1. So that means we're going to take 10 milliliters of solution 1, our stock solution. We're going to put it into our smaller flask. We're going to top that up to the V2, the final volume, which is 100 milliliters, and that'll give us a precisely 100 ppm solution of our fluoride ion. So let's do that. Let's take off the parafilm. So we need 10 milliliters. So we have a 10 milliliter pipette. So I'm just going to use a pipette bulb. You should have learned how to use these in first year chemistry. Just to refresh your memory, make sure the air is out of the bulb. This button here takes your solution up into your pipette, and this bulb over here is indicated by the E, it empties it out. Okay? So we're going to take up 10 milliliters. And again, we want this to be accurate, so when I get close to the 10 mark, I'm going to get at eye level with it. So we can make sure it's exactly 10. There we go. I'm quickly going to put this into the smaller flask. There's the 10 milliliters. And then we're going to top that up with water. So I'm going to start off by using a beaker. And like I did with the other one, I'm going to do that until I get close to the line. And then I'm going to slow down and use the bottle that I can control better. So I'm going to get about 2/3 of the way up and give it a little swirl to mix. Then I'll continue. So I'm getting close to my line here. So again, I'm going to take my bottle of distilled water. I'm going to get an eye level with the meniscus. And again, we're going to add it slowly until we get to the meniscus, until we get the meniscus touching that line. There we go. Okay, so the bottom of the meniscus is on the line. Again, I want to make sure that this is evenly distributed. So I'm going to take some paraffin just to seal the top. And we'll invert it a few times. You should probably do this at least 5 or 6 times to make sure it's properly mixed. So now we have our 100 ppm solution. So I want to dilute that down even further. So the next one I'm going to do is a 4 ppm solution. Okay, so in this case I have a 4 ppm. Again, I'm going to use 100 millivolumetric in this case. So let's go back to our formula again. Our C1V1 equals C2V2. Now our concentrations have changed. So we're going to take our 100 ppm and dilute it down to 4 ppm. So in this case, our starting solution is our 100 ppm. Okay, so that's what we're starting with. So that's C1. V1, again, of course, is what we're looking for. C2, in this case, the concentration we're trying to get to is 4 ppm. Okay? And the volume of this flask, or V2, is going to be 100 milliliters again. So if we go back to our formula again, if we solve for V1, now we need to take 4 milliliters of C1 into our next flask. So let's do that. Now I'm going to get another pipette. In this case, I'm going to use a 5 ml because I need 4 milliliters. Put those on. When you're putting these bulbs on, you don't want to have it too tight, so that's hard to get off. But you want to make sure it's on there securely. So we're going to go up to 4. Again, I'm going to get an eye level with this. I'm going to get my other flask ready. So if we go up to 4, here we are. Put this into the other flask. And then we have our 4 mils in there. Again, I'm going to top this one up with water. Until I get close to the top, and then I'll stop again and use a bottle like I did before. Okay. And again, I'm going to get an eye level so I can see it clearly. So at the bottom of the meniscus, at the line, give this one a shake. And now we have a 4 ppm solution. All right, we're going to do one more that's a lower concentration. In this case, we're going to go down to 1 ppm, so this is 1.00. Okay. So when we get down to the low volumes, a pipette is not always accurate enough to get down to that low volume. So what we're going to use for this volume is a Eppendorf pipette. Okay. So this is an Eppendorf pipette. Just to familiarize you with how these work, this is a 1,000 microliter pipette. So 1 milliliter is 1,000, if you can see that, is 1,000 microliters. Okay. So this pipette is set to 1,000 microliters, which is 1 milliliter. So we've already done our calculation for final concentration of 1 ppm. I'm going to leave this calculation for you to do. You should have got V1 equals 1 milliliter for this calculation. So we're going to use our 100 ppm solution again. And now I'm going to take 1 milliliter of that solution. So we just get a tip, pipette, make sure it's on there. Now this is not going to fit down in the mouth of that flask. So I'm going to take a clean, dry beaker. I'm going to pour a little bit of my stock solution into that. You want to make sure your beaker is clean and dry. It's important that it's dry because, of course, if you add any water to that, then you're changing the concentration, and we don't want to do that. We want accurate concentrations. So we're going to make sure the beaker is clean and dry. Okay, so we're going to take 1 milliliter, 1,000 microliters, put it into our next volumetric flask. And when you use your Eppendorf pipette, you push down to the first stop, put it under your solution, let it come up. When you're going to take it out into your solution, and I'm not going to do that again because I just did it, but just to show you, you go to this first stop, and then to get the little drop off the tip, you go to the second stop, and that comes off. The third stop removes your tip. Okay. So the Eppendorfs are useful when you get into smaller amounts. Okay. So now I'm going to fill this one, and again, same thing. I'm going to use my distilled water. I'm going to fill it up to the line. And this one, I'm just going to use a little bit of the water from the bottle in my beaker. Top that up. So again, I'm just using a beaker or the bottle to get close to the line, and then I'll slow down when I get close to it so that I don't go over. Okay, come back to my bottle, come back to eye level. I want to get rid of any bubbles on the side because that can affect my viewing of the meniscus. And there we go, all right, the meniscus. And the more you do this, the better you'll get at getting right on the line for that meniscus. I'll seal it again with some parafilm so I can mix it. You want to do this with all of your standards. So now you can see what we've done. We started with a 1,000 ppm solution. We diluted that down to 100 ppm, then to 4 ppm, and finally to 1 ppm. So we can use that same calculation for any final concentration that we're looking for to get a series of standards. Usually when we're doing an experiment, we do probably 5 at a minimum standards. Sometimes we do even more, but it's the same procedure to be followed for any substance, for any element that we're looking for. Thanks for watching.